Alright class, this was our notes for today, October 23rd, algebra. We were working on simple interest as a reminder from last Friday. Your homework as a reminder is to complete the Algebra 3-5 Simple Interest quiz on IXL. It is 5 questions. We again reviewed 2 formulas. We've got one equation that is on your reference sheet that talks about the current amount of in an account or some balance based on the principal or initial amount that you deposit, the annual interest rate when written as a decimal, and the amount of time in years. We also have this other equation, lowercase I equals PRT, where I is the interest earned, how much money somebody makes in their account, given they had some initial principal. R is the annual interest rate again as a decimal, and T is the time in years. So we talked about this. Tanya opened up a savings account with $2,100. The bank offers an annual simple interest rate of 6%, and we want to find out the amount in Tanya's account after each number of years. So after 3 years and after 8 years. Since we're interested in the total, we want to find the amount total. For A here, for part A, we used the regular equation. A equals the principal times 1 plus the rate times the time, number of years. And we took a little bit of time just to identify things. So we identified 3 years was T. We talked about our simple interest rate of 6%. We said 6% is the same as 6 over 100. 6%, think of cents, think of coins, 100 pennies, 6 over 100, which is the same as 0.06. Some of you were able to tell me how to turn percentages into decimals by putting a decimal place and then moving it once, twice to the left. And we had a principal of $2,100. The principal was $2,100. And one approach was to just plug those numbers in. 2,100 times 1 plus the 0.06 times 3. Carter actually went ahead and did 6% of 2,100, was able to tell that, and then he was able to tell us how much would be 3 years of that amount. But we'll see that again in a bit. We went ahead and did this calculation. We did 2,100 times 1 plus 0.18, which was 2,100 times 1.18, which in a calculator was 2,478. So after 3 years, Tanya would have $2,478 in her account. We then decided to approach part B another way. We decided to use the amount of interest earned to see how that would be different. I, being the amount of interest earned, should be the principal times the rate times the time. Luckily, everything is basically the same. Our principal is still 2,100. Our rate is still 0.06. And our time is now 8 years instead. We multiplied all that out when you got 1,008. So what this means is that the interest earned, notice it's the interest earned, is $1,008. So Tanya's earning $1,008 after 8 years, but that's not how much she has total. If we want to find the amount she has total, we're going to have to add up the interest earned and the principal. Our total is generally the principal plus the interest earned. So for us, that would be 2,100, or for Tanya, that'd be 2,100 plus 1,008, meaning she has a total of $3,108 after 8 years. It wasn't that bad. It was just basically plugging in numbers into a formula. And the only difference between these is, were you finding the total amount at the end already? Or were you finding a middle step? Were you finding the amount of money that somebody earned, but not how much they had total? I is the interest that they earned during that time, but you would want to add that to the principal to find the total. We then took a look at example 2 and had a similar situation. Jackson opened a bank account with $5,000. The account earns 9.5% simple interest every year, annually. After how many years will the account balance be $15,000? We're going to round to the nearest tenth if necessary. I asked the class which formula approach people would like to do, and Lariah opted to use this formula first, the I equals PRT, so that's what we're going to do. And we labeled this Lariah's way. Since I, the interest earned, is equal to the principal times the rate times the time, we need to know what I was. We need to know how much Jackson's account I increased, how much his account, how much interest he earned. Well, if he starts with $5,000 and he wants to have $15,000, I would be his increase. His increase would be $10,000. And our principal's still easy to identify. It's the 5,000 we started with. Jackson started with 5,000. The rate is that 9.5%, 9.5%, which you all told me to turn into a decimal by moving once, twice, calling that 0.095. And T was unknown. We wanted to know how many years. We want to know how many years. So we set up our equation, I equals PRT. We plugged in I, the interest earned, was 10,000. We said that was equal to 5,000 times the rate of 0.095 times the time. We decided to multiply 5,000 and 0.095 together. In our calculator, we said that was 475. We had 475 T then equals 10,000 And you've done this before. To get t by itself, we divide both sides by that 475. We found we got 21.05. There were some other decimals, but we stopped there. And with our answer, we rounded to the nearest tenth, so we said 21.1 years. This way could work. It worked. It has an answer. We're finding that Jackson wants to have $15,000 after depositing $5,000. He's going to have to wait 21.1 years. That's like 21 days and about a month, a little bit more than a month. 21 years and about a month. That's a long time to wait to earn $10,000. We then took a quick look at the same problem, but using the other formula. We said A equals P times 1 plus the rate times time. And again, we know what the total account will be. We said A was $15,000. And we said that equal our principal of $5,000 times 1 plus the rate is still 0.095 times T. Now, to make this a little bit nicer, we distributed it. We distributed 5,000 to both of these. And we saw that we had 15,000 is equal to 5,000 plus 475 T. Now we took a quick break here to just comment on this equation. What kind of equation does this look like? Well, if we think about it, Jackson's starting with $5,000. And T's the number of years. So this is saying, like, he starts with $5,000 and he's earning $475 every year. That was important for us. So we identified key features of this equation. This 475 is kind of like a slope for us. It's how much Jackson earns in his account every year. And the T is kind of like our X variable. So we have a slope, an X variable. He's starting at $5,000, so that's with no time passing, he's starting at $5,000. That's a y-intercept for us, which we're going to, as a reminder, is called B. And the 15,000 is some y value that we're solving for. We saw that it looked like y equals mx plus b. That was the goal. And then we approached it. The advice was we're going to subtract 5,000 from both sides, which got us to 10,000 equals 475t. And then we're back to the exact same steps that we had here. We found t was 21.05, or t equaled 21.1 years. Again. These notes were completed in class. As a reminder, you need to complete the Algebra 3-5 Simple Interest quiz on IXL. 4 of you have done it so far. Thank you to those 4. If you need a reminder what the questions are, there are the 5 questions on the back. If you do these 5 questions on the back, you'll have done the IXL quiz, basically.